My name is Michael, and I'm gonna talk today about deploy and destroy testing environments. The origin of this title comes from 3 years ago when a friend tried to capture a sushi plate, and I photobomb with this shirt of deploy and destroy. So then I decided that I have to invent some talk to use the title. And a bit about AppsFlyer. We're a leading mobile attribution company who help app marketeers to understand how to spend their budget. But let's look a bit at the numbers. We're around 120 people in the R&D. We have hundreds of microservices, thousands of servers, and we're handling around 80 billion events per day. Means that we're quite at huge scale, and we need somehow to maintain it. And like every other company with the growth of the R&D, with the growth of your code base, the velocity is going down. At first you say, okay, maybe I need to improve something, maybe I add tools, maybe I add some tests, and we see some small jump in the velocity. Then maybe we are lacking of documentation, we are lacking of guidance for new employees to understand how to develop and how to work on the system. And then someone says, yeah, let's do microservices all the way down, and the velocity even goes slower. And someone says, yeah, sure, let's add CI, let's pipelines, etc., which is all nice. And I'll try to show how we can increase it a bit more with dynamic dev and testing environments. So in the spectrum of test pyramid, which tries to describe some model of cost value in terms of unit tests are the cheapest and have the highest value, of our good tests is harder to implement, but also have a value, my talk would be around here. We try to see how we can leverage the integration tests and GUI tests with such system. Where it all begins. So the classic model is 3 environments of development, which can be either local or remote. Then we have the staging or the test environment, which are usually static. Once we push our code and we want to make sure that our code is good enough before deploying to production, we usually deploy to some test staging environment. And if everything goes right, we deploy it to production. But it's quite good. It's better than nothing. So shared dev and test environments are easy to maintain. Usually they have low overhead. And you have a free dependencies, right? If you have 200 microservices, 300, you shouldn't really care about your dependency deployments. You just have them inside that environment. And it's similar to production. For those developers that keep using Windows for their development, at least we see how the code is running on the same platform as the production. But it has some trade-offs. First one is fuzzy version control. It means that we never know actually what is the versions, which is the code running in the shared environment. Maybe I deploy today my code to the test environment, but later on 2 hours after some other teammate deployed changes. I can never be sure what's running in that environment. Stability, who's actually responsible for that environment? What happens if it falls down? Does the DevOps handle it? Does the developers? It's never clear the boundaries of the responsibility. Shared state and mutability is probably the main concerns. You have a shared database, you have a shared state across your development, across your state. The chances you collision with other tasks is quite huge. And usually I heard many people that updated their schema, added some new database, and someone else just changed it because it wasn't good enough for their test. It's always so fuzzy. And I'm leading to the next point of let's treat it as a cattle, not as pets. Dev and test environment shouldn't be something like snowflake that we need to maintain and make sure it's healthy. Test and dev environment should be something that is easy to create, easy to reproduce, and easy to maintain. And I try to figure it myself, what are the key principles to have such tool? And I reduce it to 4 main points: definition, interaction, safety, and usability. The first one is trying to describe environment as a human readable schema. It shouldn't be something that existing. It should be something that we can describe in words, in something that every person, every technical person can understand. We want the interaction with that system to be via API. UI and CLI are enhancements or something that helps, but they're not the core of the product. API should be our enablement to create and maintain the environments, and everything should be via API. That leads to a self-serve platform which we're aiming to. Safety, isolation. Obviously, we don't want different environments to interact with each other. Especially, we don't want the production environment to speak with the test environments or vice versa. So isolation is the key to safeness. And composable. What I mean by composable is that this tool of creation should be a building block, should be something that every person at a company can use to leverage in their own systems. And that's why we created Namespace. It's an internal system at AppsFlyer which helps people to create testing environments without dealing with the infrastructure. What do I mean by that? The key features of the system is the environment is a JSON file. They just create a schema that describes how the environment is look like. It's fully self-serve. We have APIs for everything to maintain the environment, whether it's creation, updation, and delete. We have isolation between environments. None of the environments are interacting with other ones, so we provide safeness. And the most important, it's a building block, and I'll show later in this talk how we leverage that system. It's based on two main concepts, services and resources. Every environment have a set of dependencies. By dependencies, I mean we have our own code, which is usually our services, and we have our backends, which can be MySQL, Kafka, any database, any queue, anything that you need to be part as your environment. So we separate those both as part of the declaration of the environment. The main technologies we used in namespaces is Mesos, Marathon, Docker, Traefik, and Consul, where the first layer is the orchestration layer. Mesos and Marathon, for those who are not familiar, is similar to Kubernetes in terms of orchestration platform. And we're using Traefik, which is dynamic proxy, similar to HA proxy, for those who are familiar, and Consul for the service discovery and communication. With those technologies, we managed to create dynamic environment creation. So remember the key principles I just talked before? Let's see how we apply them to namespace. So how a namespace definition, how a namespace schema looks like. The first attributes is namespace name, environment type, and global environment variables. As you can see, I emphasize namespace and F type for a purpose. Usually, environments have their own scope, their own definition. If I have a test environment, I want the test config to get up. If I have a dev environment, I want the dev config to be up. We have different set of configuration and attributes, so the way the runtime works in different types of environments. But that doesn't mean what's the scope, what's the name of the environment. So if I'm developer one and there's another developer in my team and we want both to test the same system in test, say that the environment type is test, but my namespace will be Michael and his namespace would be Yosio or some other name. We have a full separation between the environment with exactly the same behavior. And then we have the environment variables, which we can inject environment variables and override configuration or other stuff if we want. We have the service details. That's the way how we describe which services we want to have as part of the environment. So we have the ID, image, and common details, which I'll explain a bit later. The ID is the unique identifier of that service, of that app in the environment. ID helps us to communicate and distinguish between different apps in the environment. Image is the spec of how we describe which application do we even want. So it can be the service name and the version. And then we have the resource details. It's a separate part that defines what are the resources we want as part of the environment. You can see the difference here, that here we just ask for a name rather than for an image. We ask for a name because we try to simplify and we created a pool of resources behind. So name is actual reference to a predefined resource, whether it's MySQL, Kafka, or any third party you're using. And lastly, the common details, which are the explanation of how the application behaves and what it requires. So We have obviously the port that the app or the resource expose. We have the amounts of CPU and memory we need for that application to run. We have the health check definition to explain even whether the application is healthy or not. Does the deployment work well or not? And we have ability to override the environment variable per specific resource or app. Another thing about the resource and the service separation, the reason we separate between those is two things. First, so you can actually see inside your JSON your services and your backends for clarity. And second thing is to create deployment dependencies. Usually we want our resources to be up first and then the services. That's how we provide a guarantee that first the resources will be deployed and run, and then the services gonna be deployed. Let's look how it actually looks in real life JSON. So we have a namespace called DevOpsDays Tel and with one environment variable of conference Scala days. Then we have our service Hello World of Pi Hello World name with port 8080, one health check. I'm taking the latest version. The latest keyword, it tells the system that just take the latest built version of that service. And we have another environment variable which conference that overrides the previous environment variable with DevOps days. And then I added memcache because it's a high-scale service and we need somehow to manage the load, so we have another cache layer. We managed to answer the principle of environment as a human-readable schema. It's something that every technical person can understand, can create, and can manage. Second thing is the API. As I mentioned, this platform is fully self-serve, and for that we need a set of APIs to maintain the environment. So we have the creation, the read, the update, and the delete API. We have the ability to create new environment. We have the ability to read a schema of different environments. If we want to fetch a config or a schema of different environments, we have the ability. If we want only to change one service or one resource as part of the environment, we just send an update query. We don't need to fully recreate the environment. We just can update a specific scope of that environment. And obviously, we can delete. So we fulfill here the deploy and destroy constraints we mentioned. And also there's another set of endpoints that I haven't mentioned, like status, refresh, logs, and other helpers for the maintenance of the environment. Cool. That's how it eventually looks for those people who are looking for UI. Inside of Marathon, we have some idea of group dependencies, and Marathon displays them as directories. So basically, when developers, QAs, any technical person opens Marathon, they just can find their environment, click on the directory, and see what the resources and what the services are running. Cool. So it's fully API-driven and self-serve. Everyone can create an environment, and that's really important principle for this system. We don't want to maintain it. We don't want to be the guys that, please create me a new environment. Like in usual companies, when you have maybe some operations group and people coming to you saying, yeah, please create me a new environment. No, I want it to be fully self-serve. Let's take a look a bit about the communication and service discovery inside that environment. So as I mentioned, we have two main fields, the namespace name, which distinguish between different environments, and we have the ID, which describes the unique identifier of that app. We take it together and compose it to a URL code, the namespace.id.suffix of AppsFlyer.com domain. That's the way we create a service discovery. For every environment, we create FQDNs that resolves to that specific environment. Internally, all of those CNAMEs are resolving to only one server, which is the proxy behind that environment. So with every environment, we deploy the Traefik proxy I mentioned before, and Traefik is our ingress controller, is a part that maintains the entrance to that environment and the routing inside. All the CNAMEs of the services are resolving to that proxy. Is that clear? Good. So how we can make sure that the services and the resources actually communicate with the dependencies inside the environment? We're using resolve conf. That's the magic. We just add domain search as part of every container, which says always try to resolve the CNAMEs inside your own scope. We can see in this example that we're just using short names for the communication. It's enough to write the ID as your CNAME to find it. Internally, it will be resolved to the FQDN of it. So if we had the hello world service and we just try to curl it inside the environment, it will be expanded to hello world.devopsdays.appsflyer.com suffix. If you want to communicate with the memcache we created before, exactly same way. What happens if you want to talk with different environments, with production or with different namespaces? We just add the suffix of the environment. That's the way we can explicitly tell that we want to communicate with different parts of the system that are not part of our namespace, that are not part of our environment. This also helps us to understand configuration and see when people are communicating inside the environment and when they want to communicate outside of the environment, it's really explicit and understandable. Cool. So for those who are familiar with Kubernetes, this kind of reassembles the service model of Kubernetes. For some reason, they steal our ideas how to do that, but you know, it's open source essentially. So we achieved isolation, but not really. The isolation is DNS-based, means that eventually if someone wants to refer to a production resource, they still have the ability. So we decided to go for the DNS convention for two parts. First one, if we'd block the network, we'd block the VPC internally for every environment, the system would be bad. Like, I'm a new developer and I want to create a new environment. Usually I don't even know what are my dependencies. So I want to discover them and I need to start from some point. If I block all the communication outside, the first bootstrap, the first creation of the environment will be quite hard. And the second reason is that sometimes we do want to communicate with outside resources. To solve that, in next versions, we'll allow to send an attribute saying, do you want to have isolated network or not? That's the way we do support people that do not want in any manner to communicate with production. And for people who still want to communicate with other environments that are outside of the testing scope, can do that. It's the choice of the environment creation owner. Composability. That's a real-life example of integration of that system to our GitLab system. GitLab is our version control system, and we're doing merge requests or pull requests for every change we're doing in our code bases, in our services. So here's an example of one of the developers that created a new branch, a new merge request, pull request with a change, with a bug fix. And GitLab sent a request to our system to create a new environment. We can see that they have its own private environment with its changes, which is cool. If I want to check his changes, especially if the service is UI-based, I can easily go to that merge request, open that link, go to the environment, and see the changes lively before merging it to the code base, before merging it to production. It's API driven by design, as I mentioned. We can use it anywhere we want. If it's part of our CI or CD pipelines, if it's part of our Selenium or UI builds, if it's part of any schedule jobs, you have the full control to choose in which life cycle you want to use the system. You're fully owning the life cycle of your environment. Composable, which is good. But so good and nice, right? I'm just telling such a good things. It's composable, it's safe, it's nice, but it's never like that. And implementing the system was quite hard. We had tons of production and other issues that we tried to solve. The first one, and obviously, is Docker. We have around 1, 2, 3, 4 bugs. All those are real bugs of Docker that we had in production. I think we had different 5 versions of Docker, and every single one of them had critical bug. We managed to overcome that by some utilities that are sitting on the nodes and just fixing those Docker bugs. I can explain it offline because it's not the nicest fixes, but it helps to work with Docker in our workload. Infrastructure utilization was also a concern. The first design, we tried to figure out whether do we want to spawn up new instances for every environment, or do we want to have a common pool of instances and leverage them. Eventually, we choose Mesos and Marathon that are working on a predefined pool of resources. So this picture was taken a few days ago, and we can see that with 60 agents, or with 60 worker nodes, we're running around 612 containers for over 55 different environments. And the utilization is quite nice. You can see that the most of the utilization is memory. Because usually people, when they deploy the application, they need more memory to avoid of memory exception or other problems. CPU is usually a compressible resource, so nobody really cares in their test environment if the request takes a bit longer. They just care that it won't fail in the test environment. Service discovery was also a tough part. So as I mentioned, we're using Marathon, and Marathon provides us event bus, which we can subscribe and get all the events of the deployments of that environment. We found out that sometimes we have delayed messages and even losing messages. So we overcome that issue with another tool that syncs Marathon to your environment. So as I mentioned, inside every environment, we have the proxy that helps in the discovery and the communication inside the environment. And we have this tool that helps to sync periodically against Marathon. That's the way we avoid inconsistencies inside the environment. Data replication, which is also a tough issue. Usually when we create test environment, we want to have real-life data, or at least a subset of it. And for that, we went with the design of let's delegate it to the data owners. We help them to create the replication jobs. We help them to create the containers of their database. But the ownership of the data is by the team. They decide which data they want to replicate, want to take the snapshot, and we help them to create the infrastructure for that. Means that currently for a set of database, we have either 1 hour or 1 daily snapshot of the data, usually a subset of the data. It's stored somewhere in S3 bucket, and when people create a new environment, they can just specify which snapshot version they want to take. So you can actually have your own production data, or a subset of it, usually you want a subset of it, inside your testing environment. Debuggability is also a problem, because usually in dynamic environments, people never sure what happened to their service. One of the main problems is out of memory. People does not aware how much memory does their services actually need. When we previously sat on bare metal or on VPS instances, we have usually large constraints, 16 gigs of memory, many cores, and people doesn't even know how much actually resources they need. And when they started to use the system, they set up, yeah, I think I need 1 gig, 2 gigs of memory. And it never was like that. Some of the services had a heap size of 5, 10 gigs, and they defined a constraint of 1 gig of memory. And they just had out-of-memory exceptions all the time. It's quite worth to mention that we need somehow to make the observability of the system clear. We need somehow to expose these errors in a way that every person can understand. If the container crashed on exit code 125, nobody will know what it means. But if you can translate this information into some line that says, yeah, your service is crashed because of out of memory, it's something that everyone can understand and use to fix their environment. Stability is also a point. When my environment is not up or not running, whose fault is that? Is it a platform fault or developers or a technical person fault? So again, usually it's out of memory bugs, and observability is a way to explain where the issues happen, whether it's on our side or on their side. Logs metrics, yes, please do that. And last key is that essentially what I described to you is another deployment tool, and you need to consider that. It's in terms of deployment, we don't want to have the same principles we're doing in production. We don't want to have blue-green deployments. We don't want to have canary deployments inside of testing environments. We want to get into the point as fast as we can. So ideally, we want to leverage our deployment mechanism, our orchestration layer, whether it's Kubernetes, Mesos, Nomad, or any tool you're using as your orchestration layer. But the interface itself should be different. You should provide a schema or something that's readable and reproducible for testing environments. While for production deployments, you usually want to have strong pipelines that are testing and validating your changes before deploying to the production. It's different concerns, different aspects, and ideally we do want to leverage one system that manages our resources in production. My 2 cents from all these projects, it's a product. Like, it's not another DevOps hack or tool. It's a product for anything. Developers are using it. QAs are using it. People rely on that system. You should provide metrics. You should provide a nice API. You should communicate with bugs. You should treat it like any other product your company is developing. And it's really important because it's the key for the success of that product. If you're treating it like, yeah, I'll just hack some Ansible script and I'll create an environment, that's maybe fine for a 20 developer scale, 50 developer scale. Once you pass the 200, 300 members, it doesn't work. People don't care about your hacks. They want something nice. They want some UI. They want API. They want the ability to create by themselves the environments. So to recap what we learned today, static environments are good, are okay. It's definitely better than nothing. But dynamic environments is where you need to strive to, is where you can actually leverage the scale. Simplify as much as possible, so going in the design of API-driven is good. You should expose all the things you can in API. Creation and managing should be as API. The KPI for your product is developer QA happiness. If they manage to create new environments, if they manage to maintain them, means that your work is good. If you receive messages every day of, it's not working, I'm not sure how to create environment, can you help me? And you need to babysit the system, means that somewhere in the process you missed something. Treat the KPI as good. Keep it layered. So I mentioned lots of time in this talk, this whole system I described is a building block. I don't try to solve all the problems of testing. I actually even don't know all the complex pipelines of the Selenium builds. What I do know that with my system, they can spawn environments with the resources and services they need for their Selenium pipelines. I provide them the infrastructure and the components for their pipelines. And you shouldn't strive to over-engineered solution, like some of them mentioned here. But if you do, it's fine enough. It depends on the scale. I do believe that building blocks are better than a full-blown solution. And nobody cares about your Docker problems, really. Like, none of the developers came to me, yeah, I know it's because of the Docker bug you mentioned in the previous slides. Nobody cares. They want the product to work. So if you need to change your technology, to hack your way, to fix the code of Docker and send them a pull request, do everything you need. Nobody should be aware of your internal dependencies. Nobody should try to fix them for you. If you have a Docker bug, it doesn't mean that they need to change their code to be compliant with the bug. And if you remember our agenda, I hope that after this talk you understand how such environments can increase back a bit the loss velocity that's caused by growth. Thank you. Questions? Yeah. How long does it take? I think the first version we managed to hack in 2 weeks, just a prototype. And after the whole production, debugging, Docker bugs, etc., I think it took us 2 or 3 months to get it to a stable phase. 2 people work on that project. Yeah.
What do you do about resources? Actually, how much time it takes to provision an environment?
Depends. So I think the fastest environment can be spin up in 1 minute. environments with 20, 30 services with large load time can take up 10, 15 minutes. It really depends on your team, on your dependencies.
But what about, do you have services that takes a lot of time to provision? Did you have something like that? And what did you do it?
Yeah, one of the examples is the database snapshot that I mentioned. So part of the teams have quite huge databases. Means that only the container of the database startup time takes at least 10 minutes. What do? Nothing. If the person wants to wait 15 minutes, that's fine enough. It's his choice. But if he wants to lower the time, we can create a different solution. For the database thing, we just can create a pre-baked Docker with the data inside, so you don't wait for the snapshot download. If your service takes up to 10 minutes bootstrap time, we need to debug it, figure out why it takes so long, but I can't magically reduce the time. Yeah. So the question was open source. It's not yet, but you can see my email down there, and if any one of you was curious about that and want to join, we're looking for people that will help us to improve, enhance, and open source that system. Hopefully, in the next year, we do open source it, but join us. Another questions? Yeah.
I was wondering about the separation between the system and the actual deployment, the production system.
Good question. We do have other deployment tool for production. We're not using Mesos Marathon for that.
Yeah, but why not use this amazing tool we built to do actual deployments?
Because the slide I mentioned here, I don't do any of Canary, Blue-Green. I don't do any validation. I try to spun up the environment as fast as I can. And in production, you do want to have validations. So we're done. Thank you.